Consciousness, that mysterious inner experience that makes you, you. The fact that you're watching this video right now and experiencing colors, sounds, and thoughts is arguably the most profound mystery in the universe. Despite centuries of scientific progress, we still don't have a definitive answer to how physical matter, your brain, gives rise to subjective experience. Today, I'm going to walk you through 4 leading theories of consciousness that might just blow your mind and change how you understand yourself. Before we dive in, let's clarify what we're talking about. Consciousness refers to the subjective, first-person experience of being aware, what philosophers call the something it is like to be you. It's not just about being awake or alert, it's about having inner experiences. The color red doesn't just trigger certain neural responses in your brain. You experience redness. Pain isn't just activation of nociceptors, it feels like something. This explanatory gap between physical processes and subjective experience is what philosophers call the hard problem of consciousness, a term coined by David Chalmers in the 1990s. The first mind-blowing theory is global workspace theory, developed by Bernard Baars and later expanded by Stanislas Dehaene. Imagine your brain as a massive corporation with billions of specialized employees, your neurons, working in parallel, processing different aspects of information simultaneously. Most of this processing happens unconsciously, outside your awareness. According to global workspace theory, consciousness emerges when information gains access to a global workspace, essentially a brain-wide broadcasting system. Think of it like this. In a theater, there's a small spotlight shining on the stage, illuminating only a tiny fraction of what's happening, while countless activities occur behind the scenes in the dark. Your conscious awareness is that spotlight, capable of focusing on only a small amount of information at once, while vast neural processes happen unconsciously in the shadows. When information enters this global workspace, it becomes broadcast throughout the brain, making it available to multiple cognitive systems like memory, language, and decision-making. This broadcasting is what we experience as consciousness. The theory elegantly explains why our conscious experience feels unified and coherent, despite the brain's massively parallel architecture. What's mind-blowing about this theory is that it suggests consciousness isn't some special substance or property, but rather a functional state, information that's been selected for global broadcast. Your conscious experience of seeing a red apple isn't happening in a special consciousness center in your brain. It's simply visual information that has won the competition for access to the global workspace and is now being broadcast widely for other brain systems to use. Recent neuroscience research supports this theory. When people consciously perceive stimuli, we see widespread activation across brain regions, exactly as the theory predicts. What's more, when stimuli are presented too quickly to be consciously perceived, this global broadcasting doesn't occur, even though early sensory processing still happens. Moving on to our second theory, Integrated Information Theory, or IIT, developed by neuroscientist Giulio Tononi. While global workspace theory focuses on the function of consciousness, IIT takes a more fundamental approach, proposing that consciousness is intrinsic to reality and can be measured mathematically. According to IIT, consciousness is integrated information. Any system that integrates information in certain ways will have some form of consciousness. The theory quantifies this with a value called phi, which measures how much a system's information is integrated rather than separable into independent parts. Here's why this theory is mind-blowing. It suggests consciousness exists on a spectrum. Your brain has an extraordinarily high phi value because of its complex, integrated architecture. But simpler systems, from animals to potentially even sophisticated computers, could have lower degrees of consciousness. IIT doesn't draw a sharp line between conscious and non-conscious entities. Instead, it suggests consciousness comes in degrees. Even more radical, IIT flips the traditional approach to consciousness. Instead of starting with physical processes and asking how they produce consciousness, it starts with the phenomenology of conscious experience and works backward to identify what physical systems must be like to generate it. This leads to some controversial implications. If integrated information is what matters, then theoretically any system with the right causal architecture could be conscious, regardless of what it's made of. A sufficiently complex computer network could potentially be conscious. Some critics argue this makes the theory too permissive, potentially attributing consciousness to systems we intuitively think shouldn't have it. The third theory takes us in a completely different direction: higher-order theories of consciousness. These theories, championed by philosophers like David Rosenthal and Hakuan Lau, suggest that consciousness involves two levels of mental states. According to higher-order theories, merely having a mental state, like seeing a tree, isn't sufficient for consciousness. You become conscious of seeing the tree only when you have a second, higher-order mental state that represents the first-order state. In other words, consciousness requires a form of self-awareness or metacognition, thinking about your own thoughts. What's fascinating about higher-order theories is that they explain why we can process information unconsciously. When you drive a familiar route on autopilot, your brain is processing visual information and controlling your movements, but you lack the higher-order representations of these processes, so they remain unconscious. These theories also explain blindsight, a condition where people with damage to their visual cortex claim they can't see objects in parts of their visual field, yet can accurately guess their properties when forced to. Higher-order theorists would say these patients have first-order visual states, but lack the higher-order representations that would make them conscious of seeing. Critics argue that higher-order theories create an infinite regress problem. If consciousness requires awareness of mental states, wouldn't you need a third-order state to be conscious of the second-order state, and so on? Proponents counter that only the relationship between first and second-order states matters for consciousness, not an infinite hierarchy. The fourth and perhaps most mind-bending theory comes from the intersection of neuroscience and quantum physics. Quantum theories of consciousness. The most famous version is the orchestrated objective reduction theory, or ORC-OR, proposed by physicist Roger Penrose and anesthesiologist Stuart Hameroff. Conventional neuroscience assumes consciousness emerges from classical computations in the brain's neural networks. But ORC-OR suggests something far more exotic, that consciousness involves quantum processes occurring in microtubules, tiny structural components within neurons. According to this theory, quantum effects like superposition and entanglement within these microtubules allow for a form of quantum computation that generates consciousness. These quantum states supposedly collapse in an orchestrated manner, creating moments of conscious experience. What makes this theory truly mind-blowing is its implication that consciousness may be connected to fundamental aspects of physical reality at the quantum level. Penrose argues that quantum gravity effects induce these orchestrated collapses, potentially connecting consciousness to the very fabric of spacetime. Mainstream neuroscientists are highly skeptical of ORC-OR, arguing that the brain is too warm and wet for delicate quantum effects to persist long enough to influence neural processing. Yet, recent discoveries of quantum effects in biological systems, like photosynthesis and bird navigation, have kept the door slightly open for these theories. So where does this leave us? Each theory offers a different perspective on the enigma of consciousness. Global workspace theory explains consciousness in terms of information accessibility and broadcasting. Integrated information theory defines it as intrinsic to systems with integrated information. Higher-order theories tie it to metacognitive representations, and quantum theories propose exotic quantum processes in neural structures. What's truly fascinating is that these theories aren't necessarily mutually exclusive. It's possible that elements of each capture different aspects of consciousness. Global workspace might explain the functional architecture that supports conscious broadcasting, while integrated information theory quantifies the structural properties that make this broadcasting possible. Higher-order theories might describe the representational structure of conscious states, while quantum theories could potentially explain how these representations acquire their subjective qualities. The quest to understand consciousness forces us to confront fundamental questions about reality and our place in it. If integrated information theory is correct, consciousness might be more widespread in the universe than we've imagined. If higher-order theories are right, consciousness requires a sophisticated form of self-reflection that may be rare in nature. And if quantum theories hold water, our conscious experiences might be connected to the deepest fabric of reality. Whatever the truth turns out to be, one thing is certain: consciousness isn't just another scientific problem. It's the context within which we experience all problems.